What's good, everybody? It's been a while. I have not uploaded in a minute, and I apologize for that. I've just been fucking lazy. I mean, no, not necessarily, but I've just been busy with other things as well. But the last thing I uploaded, obviously, was just a debate between me and Hunter, so yeah. But I'm here because I've actually seen a lot of dimensionality videos, especially that pertain to power scaling or that come from power scalers. And I'm like, this is literally not it. So I'm just gonna make a dimensionality video that's actually better to understand because some of these niggas just be yapping. So Theoretical Toxic is here to save y'all again. So I covered a little bit of dimensionality, my ontology video. I didn't finish everything up because, the video would be long as hell if I did. To recap quickly, space and vector calculus is defined as a set where the elements are called points. Hear that, points. Another important aspect of dimensions is the notion of n-dimensional spaces. There are spaces where points or the elements are n-tuplets of real numbers. By special relativity or the theory of general relativity, we live in a four-dimensional space-time continuum. Although the human eye can only allow us to view two dimensions, we can experience the three-dimensional world mainly because of how the axis of movement work, or the axis of movement themselves, allowing us to deduce the fact that we do exist in a three-dimensional world, people. Yes. Now, how do we know this to be the case? Well, because we're in a three-dimensional space, we can move up, down, forward, backwards, left, right, which is literally only exclusive to a three-dimensional space. This cannot be done in a two-dimensional space or a one-dimensional space. That's how we know, and that's how we deduce the fact that we live in a three-dimensional space. At least when we talk about spatial dimensions, there are actually three spatial dimensions. Now, for every dimension, it brings about two extra axes of movements. The inhabitants of the first can only traverse left and right, the second up and down, including left and right, and the third is the fucking axes that I just listed out. Now, you're probably thinking, damn, this is following the same route as other little power scalars and how they describe dimensions. No, it's not. This is because the power scalars themselves don't have a deep understanding of mathematics like me because I'm the fucking king. But so they talk about things that we can like empirically deduce and things that only toddlers can know. Like a toddler can know what a three-dimensional space is. At least my fucking semen toddler. I think my son would have the capacity to do that if I had a son. But yeah, moving on. Getting to the mathematical nature of dimensions, right? Before we get into dimensionality, it's important to understand what a unit interval is in mathematics. A unit interval is an open interval between 0 and 1. It is a subset of real numbers. Because of the nature of real numbers, specifically how they can be used to represent points on an infinitely long line, the line segment of length 1, or for example, number 1 in a real number line, which is practically the unit interval in this case, is a part of an infinitely long line that real numbers represent points along. So this is where it gets a little bit tricky, right? It gets a tricky. Just follow the way. It do be getting tricky. Please don't ask why I'm speaking like this. I'm stoned as fuck and I'm high. Sorry, guys. Now then, right, the numbers or points in question, right, they have the same number of points as the whole line. That is to say, the number 1 in a real number line has the same points as the entire real number line. They have the same cardinality. The number 1 in a real number line has the same cardinality as the entire real number line. That's it. It sounds stupid, but it's mathematics. Mathematics, it do be like that. Continuing on. This means that the unit interval or open interval is an equivalent to a set of real numbers entirely. This is regarded as an uncountable set if you didn't know. I already explained uncountable sets in my absolute infinity video. You can check that out as well. So, how does this pertain to dimensionality? I'll explain right now. So basically, this would mean that because of how I defined dimensions earlier on, the first dimension would be equivalent to the number 1 in a real number line. That's as easy as I can put it for you. And the second dimension would be number 2 in the real number line. That's how it's actually represented. That's what it means when I say n-dimensional spaces or n-tuplets of real numbers. I'll show you a couple of demonstrations of that here, and it continues on to r to the power of n, which is a representation sometimes of like a infinite dimensions in vector calculus. Yeah, it is a representation of that. Now that entails the fact that the first dimension is uncountably inferior to the second dimension, or the second dimension is uncountably greater than the first dimension. In my absolute infinity video, I explained a little bit of cardinality of continuum, or the cardinal of continuum and power setting, which is essential here, right? In a sense that actually, no, let me not say that. I'll just say I'm explaining this shit right now. Essentially, a set of real numbers is an equivalent of a set of natural numbers when they're actually power setted. Likewise, in this case, wait, actually, no, fuck, stupid, spastic me. No, I gotta explain this again. Because the first dimension is inferior to the second dimension, and we know both of them are uncountable sets, the continuum hypothesis essentially states that there's no cardinality between Aleph null and Aleph 1. So you can view like the gap between, the first dimension and the second dimension as uncountably infinitely greater, because being arbitrarily larger than the cardinality beforehand entails the fact that you are of a greater cardinality and hence a greater set of infinity. See? Definitely not hard to understand, right? I hope so. I really do hope so. That's literally simple. Now, this carries on to every dimension, like literally every dimension is just uncountably infinitely greater. It goes on, blah, 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 yada, 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 yada. You see, this is what happens when you talk about dimensionality and things of substance. Not that, oh, we are moving up, down, forward. Like, who doesn't know that? They're like, is there anybody who doesn't know that? I don't understand why these power scales are so in-depth. But don't worry, y'all still got me. I'll always be here for you. I'll always be here to explain shit to you. But actually, I'm kind of like, yeah, let me get back to the top. Speaking of in-depth power scalars, let's address a few misconceptions that they're actually fucking... They push this narrative in the power scaling community, which is just these misconceptions that we're gonna talk about. So sit down, and now that we're done with dimensionality, let's talk about the misconceptions. So to address a few misconceptions, like I said, dimensions are inaccessibly greater than the last. I see people in character stats and profile users, so the character stats and profile users mainly being the one who say this, but no. Have you read geometry? Like, have you opened a singular book about vector calculus? I'm not even gonna say anything, bro. Let's just keep going. But essentially, they go on to talk about how the idea of uncountably infinity as a transcendence limits the dimensions, which the dimensions are supposed to be taken as being inaccessibly greater, and this inaccessibly greater transcendence is greater than uncountably infinity, which clearly we can see that they're mentally inept. They should not be talking about mathematics. Please, I plead for them to stop talking about mathematics. You still got me though. Let's keep going. Let's keep going, bro. Let's just keep going. But unless you didn't know, a singular dimensional space already has the property of inaccessibility. Specifically because for every Aleph null, my nigga, it's a regular limit cardinal, meaning it cannot be reached by repetitive successive operations of lower numbers or cardinals. So the first dimension encompasses the property of inaccessibility and the property of an uncountable set, which is greater than Aleph null, which Aleph null in itself already has the property of inaccessibility within itself. Come on, bro. We shouldn't be talking like this. Come on. So basically, right, an Aleph null cannot be reached by successive operations of lower numbers in cardinals, since the successive function is the one that's used to create greater natural numbers. Example, successive function of 0 is 1, successive function of 1 is, 2, and so forth. And since the basic language of arithmetic states that there'll always be a natural number that's acting as a successor for the one beforehand, it means that there's always going to be a higher natural number. But the repetitive successor operation of those natural numbers is not enough to create the entire set of natural numbers. That's why we denote the entire set of natural numbers as n, because there's always going to be the next number. We cannot know which next number is like the entire set in itself. That's why it's called infinite, and why it's transfinite beyond all finite numbers, which can be, repetitively stacked upon because of the language of basic arithmetics, and not only that, because of how the successor function works. Now, because of how fictional works usually misrepresent higher dimensions most of the time, it's important for fictional verse to have a mathematical basis for high dimensions that's explained thoroughly. Either that or just go down the easier route of having a reality over fiction transcendence for each dimension to qualify the scale higher using higher dimensions, since it's a part of the nature of dimension that can be experienced empirically, while the mathematical descriptions only serve to describe the differences in dimensions that we experience empirically. So now that we're almost done with like spatial dimensions, I just want to make this clear. There's technically no limit to how many dimensions you can construct but nomologically speaking, the highest you can go is like uncountably infinite, which allows for an uncountably infinite degree of movement. That's if you get it like in vector calculus or most of the quantum mechanics books for Hilbert space, it can construct up to countably infinite dimensions and at best uncountably infinite dimensions. Now the video is about to end, so we're going to be going into the temporal dimensions a little bit. Temporal dimensions is actually simpler because a temporal dimension is directly stated to be an uncountable set. We went over vector spaces having uncountable differences in size, resulting in them being equivalent to sets of unit intervals and stuff like that. But essentially, a space-time continuum geometrically is actually expressed as four vectors of reals. That is to say, similarly to how a three-dimensional space would be represented as r to the power of 3, an entire space-time continuum is mathematically expressed as r to the power of 4. Now, this, in a sense, does not mean that the temporal dimension is similar to like a spatial dimension. It's treated as a separate vector, right, in special relativity, but it's still a vector in itself, at least in special relativity. That's why they express it as an addition to the spatial dimension, but, having a different function to the spatial dimension. Now, to explain this more concisely, right, time essentially records infinitely many snapshots of the universe. And I mean uncountably infinitely many snapshots of the universe, which form spaces for the past, present, and future, existing not only in a linguistical denotation or a linguistical sense, but having ontological denotations of events, meaning that these events, like the past, exist mind independently. I'm sorry if it sounds like philosophy blabble in the way that I said it beforehand. I just didn't know how to put it, but I put it in a simpler way for you, so I hope you get it. But essentially, it means that the past exists mind independently, so it's not like some construct that we assign to the memories that we've experienced of something that happened beforehand. So essentially, all of these events past from the past, present, and future make time an uncountable set for recording uncountably infinitely many snapshots of the universe. It being an uncountable set is another addition to a three-dimensional space that contains about like three uncountable sets as well, which are uncountably infinitely greater than the last, meaning this is how we deduce time, or a space-time continuum to be expressed as r to the power of 4 in itself. Yeah. Basically, this means that the entire space-time continuum is an equivalent of a four-dimensional space expressed in real numbers. So destroying a space-time continuum is an equivalent of destroying like a fourth-dimensional hyperspace or something like that. But in general, even in relativity, we learned that space-time continuum is an uncountable set M representing potential and actual point size happenings, so events in spatial coordinates. So yeah, that's just about it. I would go into abstract vector spaces as well, like Hilbert space, but that's a video for another time. I hope y'all enjoyed it. And yeah, man, we gotta stop the yapping, and I'm here to stop the yapping. So everybody enjoy their day. And I don't know what to say, so peace.